Welcome back to the ninth lecture of the data science series. In this lecture, we'll be talking about regression modeling, where we'll be covering two topics, which will be demonstrate estimation model evaluation using Python and demonstrate stepwise regression using Python. Now, let's get into the regression modeling. First of all, what is regression modeling? Regression modeling is a statistical approach used to identify relationships between a dependent variable outcome and or more independent variables predictors. It enables analysts to understand relationship, predict outcomes, and optimize decisions to examine how changes in predictors affect the outcome, forecast future data points based on patterns observed in historical data, and identify significant factors to make data driven decisions. Now, there are four types of regression modeling: linear regression, logistic regression, polynomial regression, and stepwise regression. What is linear regression? Linear regression is a model of a straight line relationship between variables. Regression, as you can tell by the name, it is used when the dependent variable is categorical. It means if we want an true or false or like yes or no in that case. Polynomial regression handles non-linear relationships like where polynomial equations are used. Fourth is stepwise regression, which is the best predictors iteratively, which we'll be discussing further in this video. So, first, let's demonstrate estimation model evaluation using Python. Model evaluation helps ensure that the regression model you have built accurately represents the data and can generalize well to unseen data. Common techniques include mean squared error MSE, R squared value, and cross validation. Now, let's get into the code of this. Let's start with model evaluation. Once we build a regression model, we need to check how well it performs. This is where metrics like mean squared error, MSE, and R squared come in. So, first of all, we are importing the libraries, which is NumPy and Pandas. Then we are importing functions like train test, linear regression, and mean squared error. Now we are taking a sample data where X is the input and Y will be the output. So, data preparation, we split the data set into training and testing sets. And in model training, using linear regression, we fit the model to the training data. Means we are giving the training portion of the data to the linear regression variable. Now the third step is in code is what's happening is model evaluation. We are calculating MSE and R squared for predictions on test data. The mean squared error shows how far our predictions are from actual values, and R squared tells us how much variance in the dependent variable is explained by our model. So as you can see, we have used MSE as a variable for mean squared error. Then we have given two parameters y underscore test and y underscore prediction. And for R square, we have used R2 as a variable where we are given R2 underscore score and given two parameter y test and y prediction. Now just simply print the MSE and R2 for the result. Now, secondly, we are demonstrating stepwise regression using Python. As we just talked about it, this is the best regression in all of them. Stepwise regression is a technique used to select the best subset of predictors. It involves adding or removing predictors iteratively based on their statistical significance. Now, let's get into the code of this. So, here's what happening is we are firstly importing the libraries NumPy and Pandas, and then we are also importing statsmodel.api as SM. So for data preparation, we use synthetic data for illustration. And for stepwise function, we are iteratively adding or removing predictors based on their p-values. And for result, we display the optimal set of predictors. So you can implement regression modeling and stepwise regression in Python. And in this code, see that we are here printing the result by result variable, which is stepwise selection. Here I have written the syntax of data.iloc. Here we have given the range of it to print it in reverse, then print selected features result. We have taken forward step and we have also taken backward step in the stepwise regression function. And that's how you can implement regression modeling. Thank you.